Hello everyone, welcome to my channel Analytica Vista, and today I'm going to discuss basic statistical concepts in Stata. So before we move on to actual data analysis in Stata, it is highly important to understand some basic statistical concepts, which we are going to discuss today in this tutorial. So the question for you, what is data? And I think everybody knows what is data, right? So any information that can be expressed in a numerical form, like in a number form, that is called basically quantitative data. But there could be qualitative data as well that may come in the form of text or words. But for our statistical analysis, it is important to understand that data is a numerical number. Data is information in a numerical form. So, and that's when it is suitable for statistical analysis. Okay, so now examples of data sets. What is a data set? A data set is a collection of data. So it could be sourced from a single origin. For example, the General Social Survey, which is a widely popular national level survey in the United States. And many social scientists use this data set in their research. But there could be many forms of data set. So basically, data sets are structured as matrices with rows representing cases and columns indicating variables. So let's look at the format of the data. Okay, so here is our data set in Stata. Now we are going to go to data browser view. So in this data set, you can see that we have these are the columns, the selected ones. These are the columns. In the columns, we have the variable. So the variable of population, and we have the variable for population in the urban area, for example. So these are these columns are basically your variables. Okay, and if you click on the row, the first row, second row, third row, these are the cases or values in your variable. So for example, urban population, this number, okay, in this row, this is a case or a value. So this is how a data set looks like. Okay, then we have a research process. How do we conduct a research using data? Researchers employ data and statistics throughout the research process, involving 5 key steps. First, formulating research questions. So you need to have a prior idea about your research question, how things are related to one another, how education, for example, is related to income. Does education increase income in general? So these kinds of questions. So you need to come up with the research questions, and then you need to develop hypotheses. So you might expect that yes, education is positively related to income, meaning that as people get more education, they start to increase their income. So that is the positive association. And then you collect your data from your study area, and then you have your data analysis done, and assess whether your hypothesis has been supported by your data. So these are the key 5 steps that you need to follow. Now, units of analysis. Units of analysis denote the levels of social life upon which researchers focus their investigations. So examples include micro level individuals. It could be individuals. So that is the data about the individual. That is the information about the individual. So you collect the information about individuals, their levels of income, for example. How many years of education have you completed? So they give you the number, like 16 years of education they have completed, for example. Then you collect their levels of income. How much do you earn per year? So they earn, for example, $50,000 per year. Okay. Then your data may have at different levels, like meso levels, like it could be organizations, or like schools. Like you may collect data on schools. So school is now your unit of analysis. You collect data on the level of school, like how many students this school has, this particular school has, what level of um, like GPA on average their students have. So that is the information about their school, not about the individual. So that is the meso level. And then macro level, like societal structural levels. So that those are bigger units, like the country. It's a big structural level. Okay, so you may collect the information about country. What is the GDP for United States? What is the GDP for England? What is the GDP for Bangladesh? So you collect the information about this macro unit. So depending on your unit, you collect the data. Okay, so it could be individual, it could be organizations, it could be a country, or any geographical or spatial units. Okay, now very important is population and samples. So what is population? What is sample? Populations represent the groups of interest to researchers, not the entire population of your country. It could be, but it is not necessarily. It is the population to the interest of the researchers, meaning that researchers are targeting this population group specifically to know about, while samples represent subsets drawn from populations. And random sampling, which is the process of selecting your sample, ensures each member has an equal chance of being selected, enhancing the sample's representativeness. So imagine you are interested in understanding the average income of households in a city with 100,000 households. So in a city, your unit of analysis is now household, not individual. You are not collecting data at the individual level. You are collecting data at the household level. And now so then in your city, all of the households are your population. Okay, now population is all the households in the city that you are interested in studying. Okay, and what is sample? Sample is, instead of collecting from all 100,000 households, which would be time consuming and costly. You cannot end up doing a study on 100,000 households. It would take years to complete your study, and a lot of resources and manpower and women power. You decide to select a subset of households to represent the entire population, meaning that you need to draw some people out of 100,000 households, because you cannot study all of them. This subset is your sample. However, what if your sample is not representing the population? For example, the average income in your population is $50,000 per year per household. Now, your sample, for example, you collected data on 2,000 people out of 2,000 households out of 1,000 households. Among these 2,000 households, you see that their average income of these 2,000 households is 30,000. So your sample is basically not representing your population. Okay, so you must not make any error in sampling because you want a representative sample. So how can you get a representative sample? That's where we need to understand random sampling. Okay, so what is a random sampling? Random sampling is you need to have the list of the whole population, and then you may want to generate a random number to draw your sample from the whole list of your population. For example, you may uh, get a random number of 1,000 household. So every 1,000 household, you will collect your sample. So that's how we do the random sampling. If you do the random sampling, research has shown that your sample will be representative of your population. If your population has 50,000 average income per household, then your sample will have a similar or like, if not the exact same, but it will be very close to your population parameters. Then we have variables. What are variables? Variables denote attributes subject to variation and measurement in statistical analysis. They must exhibit variation. This is very important, as constants cannot explain statistical relationships. Suppose you are conducting a study to investigate the relationship between hours of study and exam scores among college students. Now I have a question for you. In this study, what is your unit of analysis? You are studying the relationship between hours of study and exam scores among college students. Now tell me, what is your unit of analysis? Is it individual? Is it college? Is it city? Is it country? Yeah, thank you so much for the correct answer. It is the individual, because we have college students, we are studying students. So our level of measurement, our unit of analysis is college student or individual. Okay. So among these students, observe variations in both hours of study and exam scores. For example, some students studied for 2 hours, while others studied for 6 hours. Likewise, some students scored 60% on the exam, while others scored 90%. Okay, so that means you have variation. Some of your samples have higher scores, some of your samples have lower scores. So that varies across the individuals. Both the variables vary across the individuals. Hours of study, some people study less and some people study high. So they have 1 hour, 2 hour, 3 hour, 4 hour, 5 or 6 hour, 10 hours, different values in your variables. So that's why they are variables. They change, they vary. That's why they are variables. If they are constant, you cannot explain anything. So what if everyone has the equal hours of study, everyone has the equal GPA or exam scores? So you cannot explain anything. So you basically explain the variation, the decrease and increase. What increases is the exam scores, and you are hypothesizing that if you study like longer hours, you're going to get more scores. You're going to get higher scores. So you are basically explaining this variation. What explains this variation? Why some people are getting higher scores? So that you can put appropriate social policy in to improve the conditions of the students, right? If you are a policymaker at the college, you are interested in knowing what explains the higher scores of your students. So then you can put the appropriate awareness program in order to improve the conditions of your students. Okay. So now, dependent and independent variables. Dependent and independent. So dependent represent outcomes or effects. Just think effects or outcomes, while independent determine outcomes. So independent is actually causing the outcomes or influencing the outcomes. For example, the educational attainment of parents may influence college attendance rates. So whether somebody is attending college or not is actually influenced by the level of education of their parents. So if their parents have higher levels of education, then this influence their children's college attendance, right? So what is influencing and what is being influenced? What is being influenced is the college attendance, and what is influencing is educational attainment of parents. So the outcome is, or dependent variable is, college attendance. That is the result, that is the effect, that is the outcome. But the cause or the independent variable, the influencer, is the educational attainment of parents. Okay, this is very important, levels of measurement, uh, and you can actually determine how to choose the appropriate statistical modeling if you know appropriately the levels of measurement. So three levels of measurement that we're going to talk about. These are very easy to understand. Nominal, so just think about the name. So from name, nominal level. So for example, gender, it's just a name, right? Male or female. That's why it's nominal level. So this is called level of measurement, how your variable is measured. Your variable, if it is gender, it is measured at nominal level because these are names, not number. No rank, right? Marital status, single, married, or divorced. So these are names. So nominal data categorize information into distinct groups without ranking. And then we have ordinal level. So that's also name. That's also name of the variables. However, it could be ranked. Okay, for example, educational attainment, high school diploma, bachelor's degree, master's degree. But you can rank them, right? The higher is master's degree, then you have bachelor degree, then the lowest is high school diploma. And in a Likert scale or socioeconomic status, low socioeconomic status, middle, and high, so you can rank them. That's why it is the ordinal level. It has an order, okay? So from order, ordinal, okay? So it has an order. Just remember, it has an order. And nominal, no order. It's just name. An ordinal name, but it has an order. The final is also called quantitative level or interval ratio. So example includes temperature in Celsius or Fahrenheit, IQ scores, height in centimeters, weight in kilograms. Interval ratio data have equal intervals between values, with 0 representing a meaningful absence of the attribute. Equal intervals means, so if I say temperature 5, so temperature 10 is just the double of temperature 5. But in ordinal, we cannot say it precisely. Even though we rank it, uh, it is hard to say a precise level. Somebody belonging to low socioeconomic status with 19,000 income level, somebody in middle class with 40,000 income or 30,000 income. So it's a range, so not a specific number. It's because it's an ordinal level. So the intervals may not be necessarily equal. Thanks for watching, and we'll continue to demonstrate our data presentation in the next tutorials.